Let's take a look at this wheel, black and filthy, covered in brake dust so thick you cannot see the finish underneath. Welcome to Professor Hassan's lab, and hit the subscribe button. This is the kind of wheel that you have to scrub with a whole bottle of wheel cleaner that costs $14 every 2 weeks. You watch the purple chemical run down your driveway, then you watch the dust come back 3 days later like you never even touched it. This is the kind of wheel that your detailer charges you $40 to clean, knowing it will look the same by the time you drive home from the car wash. You have scrubbed this wheel before, you have bought the spray, bought the mitt, bought the foam cannon attachment, bought the coating that someone on the internet told you would finally stop the dust. The dust came back every single time because you were never solving the problem. You were managing a symptom, and the companies selling you wheel cleaner every 2 weeks were counting on you never learning the difference. So you pay $14 a bottle, $16 or sometimes more, every 2 weeks because you believe there is no other option. There has always been another option. A $1 spray that you can buy at every hardware store in the world creates a barrier on your wheel surface that prevents brake dust from bonding permanently. No scrubbing, no acid, no ceramic coating, no detailer. This is the compound that aerospace surface engineers have used on commercial aircraft landing gear components since the late 1960s. It is the formula that professional ceramic coating applicators use as a base layer and charge you $300 to apply without ever telling you what it actually is or that you can buy it yourself for less than $1 per wheel. This is the chemistry that the $4.2 billion global wheel care and brake cleaning product industry has spent over 50 years making sure never appears on the back of any wheel cleaner bottle, any detailing guide, or any dealership maintenance checklist, not because it does not work, but because it works so completely that a single application makes their entire product category unnecessary. This is the forbidden knowledge. They buried the science, and we dig it up. Before we go further, if you have ever spent money on wheel cleaner that stopped working by the following weekend, or if you are currently scrubbing brake dust off your wheels every wash day knowing it is coming right back, drop the word dust in the comments. We want to know how many people are trapped in a cleaning cycle that a $1 spray could have ended permanently. Subscribe now because the suppression section of this video is going to permanently change the way you look at every bottle of wheel cleaner you have ever purchased. If this knowledge matters to you, the subscribe button and the bell are the way to make sure this channel keeps digging. The global automotive wheel market generates over $4.2 billion in revenue. And in the United States, consumers spend an estimated $1.8 billion every year on wheel cleaning products, detailing services, and ceramic wheel coatings marketed as dust prevention solutions. The average car owner buys wheel cleaner 4 to 6 times per year at $10 to $15 per bottle, which is $60 to $90 per year, on a product that does not prevent dust. It removes dust that is already bonded to the wheel surface temporarily, and with chemicals aggressive enough, it often damages the wheel finish it is supposed to protect. Professional wheel detailing runs $30 to $50 per session, and most car owners who care about their vehicle's appearance pay for it once a month, meaning $360 to $600 per year on a service that resets to zero within a week of each appointment. Ceramic wheel coatings marketed as dust barriers cost between $150 and $400 per vehicle. And last, according to independent testing, between 3 and 8 months before dust accumulation returns to pre-coating levels. Detailing shops recommend ceramic wheel coatings routinely, and most car owners who have had their vehicle professionally detailed have been offered one at least once. It is presented as the premium solution, the ultimate answer to brake dust, the only way to keep your wheels clean between washes, and it fails within months every single time. Now here is the number the wheel care industry needs you to never calculate. Brake dust is not dirt, not road grime, not contamination from driving. It is a material with a specific chemical composition created by a specific mechanical process. That process can be interrupted at the source for less than $1, because brake dust adhesion on a wheel surface is not a cleaning problem, it is a chemistry problem, and chemistry problems have chemistry solutions. The $1 solution has been sitting on the hardware store shelf for over 55 years, and before I show you exactly what it does and how to use it, you need to understand what brake dust actually is on a wheel surface. Once you understand that, the wheel cleaner aisle is going to look very different the next time you walk past it. Quick note before we continue. The compound we are discussing is an available non-toxic surface-applied spray that creates a dry barrier film, and it is safe for use on all wheel finishes, including painted, polished, chrome, and powder-coated surfaces. Always apply in a ventilated area, and avoid breathing the spray mist. And if your wheels have existing damage, peeling coat, or structural cracks, address those issues first before applying any surface. Treatment. Brake dust forms through a mechanical process that has been understood since the earliest days of disc brake engineering. When you press the brake pedal, hydraulic pressure forces the brake pads against the spinning brake rotor, and the friction between them generates heat that regularly exceeds 400 degrees during city driving and can reach over 900 degrees under heavy braking. That heat combined with the pressure of the pad against the rotor causes microscopic particles to shed from both the brake pad compound and the rotor surface, and those particles are brake dust. The process is continuous and does not stop when your wheels look clean, occurring every time you press the brake pedal on every single drive until either the brake pads are completely consumed or the dust adhesion is prevented at the wheel surface. 92% of visible brake dust comes from the brake pad, not the rotor, and the pad compound, a mixture of fibers, ceramic particles, resin binders, and friction modifiers sheds fine particulate matter every time the brakes are applied. Those particles are extremely hot when they leave the pad surface, electrically charged from the friction process, and chemically adhesive due to the resin binders in the pad compound. When hot particles shoot off your brake pads, they arrive at your wheel at temperature carrying energy, friction, and microscopic debris that is actively looking for somewhere to bond. They embed themselves at a level you cannot see with your eyes, and this is where most people misunderstand what brake dust really is. It is not just dirt, it is a mix of metal shavings, carbon fibers, and adhesive compounds designed to survive heat and pressure. The key player is the resin inside your brake pads, which is engineered to hold the pad together under intense stress and also becomes tacky under heat, behaving like a glue that activates every time you press the brake pedal. When you brake, temperatures spike dramatically within seconds. That heat melts the resin enough to make it sticky, and the particles hit your cooler wheel surface and immediately begin to bond. It hardens as it cools, locking those particles in place, and that is why this bond is so stubborn that water alone will not touch it, and regular car soap barely affects it. Even high-pressure washing might remove surface dirt, but the bonded particles remain clinging tightly to the surface. What is surprising is how fast this buildup happens, as a wheel driven normally for just 1 week can already have a layer of bonded brake dust nearly as difficult to remove as one neglected for months. Within hours of driving, the resin begins curing on the wheel surface, meaning by the time you notice your wheels looking dull or dirty, the real problem is already set in, and you're not cleaning dust. You're trying to break a chemical bond. Most people turn to wheel cleaners that use reactive ingredients designed to break down iron particles and weaken the resin's grip, and that is why they are effective at restoring the appearance of your wheels. The problem is, they do not stop the cycle. They remove what is already stuck, but do not prevent new dust from bonding the next time you drive. Some people suggest coatings as a long-term fix, and while they can help to some extent, they are expensive and often marketed as a solution when they do not eliminate the bonding process entirely. The real issue is not how to remove brake dust, it is how to stop it from sticking in the first place, and there is actually a compound that does exactly that. It has been around for decades and was not created for cars originally. Its first real use was in a far more demanding environment. Back in 1969, engineers working in aerospace needed a way to deal with braking conditions on aircraft landing gear. So instead of constantly cleaning the landing gear, they developed a surface treatment that prevented brake particles from sticking in the first place. This compound works by forming a layer over the surface that fills in pores and imperfections, creating a more uniform finish at a level you cannot see or feel. One of the key ingredients in this compound is PTFE, a material known for its non-stick properties, and the same type of material used in non-stick cookware. On your wheels, it behaves differently. It does not change how the wheel looks or create a noticeable coating. Instead, it works at a molecular level to prevent bonding. Another critical detail is that it does not interfere with your brakes at all, since the compound is applied only to the wheel surface and will not contaminate your brake pads or affect braking performance in any way. In aerospace applications, this kind of coating has been documented for years with maintenance engineers, relying on it to reduce buildup, simplify cleaning, and maintain performance under extreme conditions. So why is not everyone using it on their cars? Part of the reason is awareness, since the automotive industry tends to focus on products that need to be reapplied frequently, and a simple low-cost solution that reduces the need for those products does not get the attention. There's also a financial angle, as the wheel cleaning industry generates revenue from products designed to remove brake dust, and if more people prevented the dust from sticking in the first place, the demand for those products would drop significantly. Despite that, some independent detailers and engineers have started using this approach, testing it on all types of wheels and in all driving conditions, with results that are consistently impressive. In many cases, brake dust adhesion drops by 90% or more. Wheels stay cleaner for longer, and when they do get dirty, a simple rinse is often enough to restore their appearance. What is more interesting is that visually nothing changes. The wheel looks exactly the same as before, with no coating, no added shine, and no alteration to the finish. Brake performance also remains completely unchanged, since the compound does not interact with the braking surfaces and does not affect how your car stops. Over time, treated wheels continue to release dust rather than holding on to it, and that is the real difference. Because untreated wheels accumulate layer after layer, while treated ones resist buildup and stay easier to maintain. Now, before applying any kind of barrier like this, there is one step that makes all the difference, and most people skip it. But it only takes 10 minutes, and it determines whether you get full, even protection or inconsistent, patchy results. That step is surface preparation, because if the wheel is not completely clean before applying the compound, you are essentially sealing in whatever contamination is already there, which creates gaps in coverage and reduces the effectiveness of the barrier. To do it right, you need a few basic things. First, a PTFE spray that you can find at hardware or auto parts stores. Inexpensive enough that one can is usually enough for multiple applications at less than $1 per wheel. Next, you will need a wheel cleaner or degreaser to remove any existing brake dust, oils, and residues from the surface, with the goal of getting the wheel as clean as possible before applying the barrier. A wheel brush helps you reach into tight areas like spokes and lug nuts where brake dust tends to collect, and pairing that with microfiber towels to dry the surface ensures a clean finish. Disposable gloves are optional but can make the process cleaner and more comfortable, especially when working with degreasers and sprays. Once everything is clean and dry, the surface is ready, and this is where the real difference starts to show, because instead of constantly reacting to brake dust, you're finally getting ahead of it. From that point on, maintenance becomes simpler, faster, and far less frustrating, because instead of scrubbing away stubborn buildup every few days, you are simply rinsing off what never had a chance to stick in the first place.